Good evening, students. How are you? Hope all of you are doing well and maintaining good health. I am Dr. Smrutirekha and I welcome you all to Etuson, Education for Better Tomorrow. Are you all interested to pursue quality education? Then you are in the right platform, as we are there to support you to build your bright future. So for that, you have to enroll yourself in the eTuition app. So what are you waiting for? Please download and register yourself. Let us go to today's topic, that is properties of rational number. Have you watched the previous two videos of mine? You have not? No problem. Please watch it. In the first video, I have discussed about the concept of rational number. And in the second video, I have discussed about one of the properties of rational number, that is closure property. So as we know that in your syllabus there are three properties to be discussed, that is closure property, commutativity property, associativity property. So out of which closure property has been discussed in the previous video or the previous class. But before going to the rest two properties, I will discuss the closure property so that there will be a little bit of revision for you and you can understand the concept in a better way. So what is closure property? Hope you remember. What was that? If A and B, what are they? Suppose they are operands. And the nature of operands, it may be natural number or whole number or integer or rational number, right? It may be of any one kind. And you are going to perform the operation like plus, minus, multiplication and division. So after performing all these operation, the result, suppose the result is what? Suppose the result is, your result is C. If this C is of same category as that of A and B, so if A and B is natural number, then C has to be natural number to to be to be to be to maintain the closure property. If not, you have to say that that particular operation is not closed for that particular number. Like for example, if you remember, suppose you have taken 3 plus 5. 3 is a natural number, 5 is a natural number, and the summation is 8. So you can say that the natural numbers are closed under addition. Suppose I'll write 3 into 5, that is 15. So you'll say natural numbers are closed under multiplication. If you write 3 is to 5, the answer is 3 by 5. But 3 by 5 is not natural number. So in that case, what you will say? The natural numbers are not closed under division. Suppose you will write 3 minus 5. The answer is minus 2. So minus 2 is not natural number. So in that case, what you will tell? So natural numbers are not closed under subtraction. Hope the concept of closure property is now revised for you and you have already understood it properly. Am I correct? Okay. Now let us go to next two property. So we will be discussing it one by one. What is the next property? That is commutative property. So what is commutative property? The commutative property refers to the ability to change the order of something without changing the final result. It deals with arithmetic operation of addition and multiplication. So most of the time it is implementable to addition and multiplication. So commutative property, the word commutative property, it comes from commute. Commute means to move all around. So let us consider this example. So here, suppose you have two box. You have two box. Okay. So you have two box here. Correct. So now you are going to add how many more box? So there are how many more box? Three box you have added. Now what will be the answer to it? So it will be 2 plus 3, that is equal to 5. 2 plus 3, that is equal to 5. Correct. So now let us do the same problem in a different way. How it is? So first let us take three box first, right? So let us take, so we have taken three box first. Then we are going to add another 2 to it. But still, what is the answer? Answer is again 5 only. So no matter whether you add 2 to 3 or you add 3 to 2, answer remains unchanged. You have changed the order, but also in general if I will write, it will be equal to a plus b is equal to b plus a. जैसे तुम रसना बना रहे हो, ठीक है? अभी पानी में रसना डालो या फिर रसना पाउडर में पानी डालो, तुम्हें तो रसना बनाने में मतलब है ना. बोथ में अगर क्वांटिटी सेम रहा तो यू विल एंजॉय योर रसना. करेक्ट और नॉट? ओके. सो होप you have understood the definition of commutative property. Correct? Now let us go for more examples where we will be testing how the commutative law can be used for different kinds of number to check whether that particular operation for that particular number it is commutative or not commutative. Let us go to first natural number. So first we are going to perform the addition. So we are checking the commutative property. So let us consider two numbers. So let's consider the two numbers as, suppose you have 4 and 5. Suppose 4 plus 5 is equal to what? 9. 5 plus 4 is what? Is equal to 9. Hence we can say for natural number, addition is commutative. Addition is commutative. Correct? Now take the same number. Suppose I'll write 4 minus 5. Answer is minus 1. Suppose I'll write 5 minus 4. Answer is plus 1. Is minus 1 is equal to plus 1? No. So in that case, we will write subtraction in case of natural number is not commutative. Is not commutative in nature. Now consider the case of multiplication. 4 into 5 is equal to what? 20. 5 into 4 is also equal to 20. So, multiplication is commutative in case of natural number. In case of natural number. Now consider the case of division. So 4 divided by 5 is equal to 4 by 5. 5 divided by 4 is equal to 5 by 4. Is 4 by 5 equal to 5 by 4? No. So we will write division is not commutative for natural number. For natural number. Now let us try all these operations for whole number. Now for whole number, which number is going to be added to the natural number? It is 0. So let us take one of the number as 0 and another number, suppose it is 5 again. So 0 plus 5 is equal to 5. 5 plus 0 is equal to 5. So addition is commutative. Addition is commutative in case of whole number. Considering the same two number, 0 minus 5 is equal to minus 5. 5 minus 0 is equal to 5. Are these numbers equal? Minus 5 and 5? No, they are not equal. So you will write that for whole number, subtraction is not commutative in nature. Now consider for multiplication. 0 into 5 is equal to 0. 5 into 0 also equal to 0. Hence, multiplication is commutative in nature in case of whole number also. Now consider the operation of division. So 0 divided by 5 is equal to 0. Whereas if you divide 5 divided by 0, that is undefined. That is undefined. So which is not equal. So for division in case of whole number is not commutative. Is not commutative in nature. Now let us test for the integers. So integers include what? Positive integers, negative integers and 0, right? So let us take one of the number as minus 4 and another number as plus 5. So minus 4 plus 5. What is the answer? 1. 5 plus minus 4. What is the answer? 1. So in case of integer also, addition is commutative in nature. Consider in case of subtraction, taking the same number, minus 4 minus 5, that becomes minus 9. But the other way round, 5 minus minus 4, that becomes plus 9. So is minus 9 equal to plus 9? No. So like whole number, like natural number, for integer also subtraction is not commutative. Correct? Now consider for multiplication. So minus 4 into 5 is equal to 20. Minus 20. So 5 into minus 4 is also equal to minus 20. So like your natural number, whole number, the integers also, multiplication is commutative in nature. commutative in nature. Now, let us consider for the division. Okay. So, I have taken minus 4, right? So, minus 4 divided by 5. That becomes minus 4 by 5. 5 divided by minus 4. That becomes minus 5 by 4. Which the numbers are not equal, right? So, in case of integer also, division is not commutative, in nature. Now, let us check all the operations for our rational number. Okay. So, so far natural number, whole number, integers are also rational number. But what is the difference is, apart from all these numbers in rational number, you have fraction. So which can be, so all the rational number can be expressed in terms of P by Q, in terms of fraction, where Q is not equal to 0. Okay. So what we will take is, so let us take two fractions. So one is suppose 1 by 2 and another is suppose 1 by 3. So I will take the LCM of 2 and 3. So that becomes 6. So here comes your 3 plus 2. The answer is 5 by 6. Let us take the other way round. That is 1 by 3 plus 1 by 2. So that is equal to, again the denominator becomes the 6. So here comes your 2 and here comes your 3. The answer is 5 by 6. So like natural number, whole number, integer, in case of rational number also, addition is commutative in nature. Commutative in nature. Now in case of subtraction, let us see what will happen. So half minus 1 by 3. So denominator is what? 6 again. So 3 minus 2. Answer is what? 1 by 6. Let us subtract 1 by 2 from 1 by 3. So 1 by 3 minus 1 by 2. Denominator is 6. Here becomes 2. Here becomes 3. So the answer is minus 1 by 6, which are not equal, right? So subtraction is not commutative. Subtraction is not commutative. Correct. Now let us check for our multiplication and division. So which number we had taken before? 1 by 2 and 1 by 3. Let us take those two numbers only. So multiplication 1 by 2 into 1 by 3. So the answer is 1 by 6. Again you multiply in the other sequence, that is 1 by 3 into 1 by 2. Answer is how much? Again the same, 1 by 6. Hence multiplication is commutative in case of rational number. Now for division. So half divided by 1 by 3. So what will be the answer? 1 by 2 into 3 by 1. What is the answer? 3 by 2. Now the other way round, 1 by 3 divided by 1 by 2 is equal to 1 by 3 into 2 by 1. What's the answer? 2 by 3. So this answer and this answer, that is 3 by 2 and 2 by 3 are not equal, right? So like your natural number, whole number, integers, in case of rational number also, division is not commutative. Division is not commutative. So what's the common thing you found out in all kinds of number? That could you recognize it? So it was lying in the definition itself. Definition of commutative property. So there itself it was written that what? For the commutative property holds good for addition and multiplication, for natural number, for whole number, for integer, and also for rational number. And it is not commutative for subtraction and division. Hope you understood. Okay, now let us go to the next property of the rational number. What is that property? Associative property. Okay, so what do you mean by associative property? Associative, as the name implies, means grouping. Origin of the term associative is from the word associate. Basic mathematical operation which can be performed using associate property are addition and multiplication. उसका मतलब क्या? अगर तुम्हें एडिशन या सब्सट्रैक्शन या मल्टीप्लिकेशन और डिवीजन करना है, ग्रुप करके अगर तुम कर रहे हो, instead of in spite of you are taking this group or that group, but the final results should be the same. Okay, so this will be clear. Whatever I have told, this will be clear with the following example. What is that example? Suppose you have 2 box, 3 box and a set of 4 box. So you have 2 box, so you have 2 boxes, 3 boxes and 4 boxes. Now all these boxes has to be packed together. So suppose initially what you do, you will take 2. So first you will take 2 and 3 together. 2 plus 3 equal to 5. Then after that you will add the other set of box which consists of 4 boxes. So what will be the answer? Let us see. So first you took 2, you added 3 to that. So here 2 plus 3 which is equal to 5 now. Now to this 5 you added another 4. So the answer becomes what? So now you have added another 4 to it. So the answer becomes 5 plus 4 is equal to 9. So here initially you have grouped 2 and 3. You added them. Then after that you added 4 to it. And the answer was 9. Now let us see the other condition in which first you have taken how much? You have taken 3. Then you took 4. So you have grouped here 3 plus 4 which is equal to what? 7. Now you added 2 to it. Okay. Now you added 2 to it. So what will be the answer? The answer is 7 plus 2, that is equal to 9 again. That is equal to 9 again. Correct. So in case of associative property, so if you group the number and add them together, the answer remains unchanged. The answer remains unchanged. So that is what is associative property. That is what is associative property. So from the previous slide, I think associative property concept is clear to you. Now let us write generalized formula for associative property in case of addition and subtraction. So we can write a plus b within bracket plus c is equal to a plus b plus c. that is equal to B plus C plus A. This is for addition. In case of multiplication, we can write it like this. A into B into C is equal to A into, you can group B and C together. That is equal to, you can group C and A together. In all the cases, your answer remains unchanged. Now let us implement this for all kinds of number. Let us start with natural number. So I'll take three numbers, 2, 3 and 5. So 2 plus 3 plus 5 is equal to 5 plus 5, that is equal to 10. Other way, 2 plus 3 plus 5, that is equal to 5 plus 8, sorry, 2 plus 8, that is equal to 10. Hence, it is, addition is associative. For subtraction, we know that it is not associative, so I am not performing it. Now for multiplication, so 2 into 3 into 5. So that is equal to 6 into 5, that is equal to 30. Okay. So 2 into 3 into 5. So that is equal to 2 into 15, that is equal to 30. So hence proved that for multiplication in case of natural number are associative in nature. So division is not associative, right? So now let us check for whole number. So whole number means I will take 1 0, 2 and 5. So 0 plus 2 plus 5 is equal to 7. Now 0 plus 2 plus 5 is also equal to 7. Hence associative nature is proved in case of whole number. Similarly, subtraction and division, we know that it is not associative in nature, so we are not performing that. For multiplication, I'll do, that is 0 into 2 into 5 is equal to 0. That is 0 into 5. So final answer becomes what? 0. And also in the other way, 0 into 2 into 5, the answer is also equal to 0 into 10, that is 0. So in case of whole number, both addition and multiplication are associative in nature. Now consider for integers. So let us take some negative integers now. Suppose I have taken -2, -1 and suppose 3. Okay. So these are the three numbers I have taken. So let us perform the addition operation. So -2 plus -1 plus 3 is equal to how much? Is equal to -2 minus 1 is -3 plus 3 is equal to 0. The other way, let us see. So -2 plus -1 plus 3. So if you take -1 plus 3, that is equal to -2 plus 2, that is equal to 0. So in case of integers also, addition is associative in nature. Okay, so for subtraction I am not performing because we know that it is not associative in nature. Now taking the same numbers, I will multiply the numbers by grouping them differently. Minus 2 into minus 1 into 3. So the answer is 2 into 3, that is 6. Okay. So now suppose I will do minus 2 into minus 1 into 3. So minus 2 into minus 3, that becomes 6. So our associative law is proved for integers in case of multiplication also. Now let us check for rational number. So first we'll take in the case of addition. So let us consider three numbers, that is minus 2 by 3, 3 by 5 and minus 5 by 6. So let us perform the operation. So minus 2 by 3 plus 3 by 5 within bracket plus 5 by minus 5 by 6. So that is equal to, so you have 15 as denominator. So minus 10 plus 9 plus minus 5 by 6. So that becomes minus 1 by 15. Okay, so let us give one bracket here also, plus minus 5 by 6. So now the denominator becomes 30. So here comes your minus 2 and plus minus 25. So the answer becomes minus 27 divided by 30, that is minus 9 by 10. Now let us take the other way round. So here, so first you will write minus 2 by 3 plus within bracket you have 3 plus 5 and minus 5 by 6. So we can take the other bracket here. So that is equal to minus 2 by 3 plus. So here your denominator becomes 30. So 3 into 6, that is 18, plus 5 into minus 5, that is minus 25. So, sorry, I have written 60, huh? So it is 30, right? So 3 into 6, that is 18, and here minus 25. So your answer becomes minus 2 by 3 plus 18 minus 25 is how much? That is minus 7 by 30. So that becomes again, so that becomes minus 20 plus minus 7 divided by 30. So answer is minus 27 by 30. So which is equal to minus 9 by 10. So your A plus B plus C is equal to A plus B plus C. Correct or not? So in case of rational number, it obeys associative So for subtraction, if you want to do, you can just check it. But like your whole number, integer and natural number, in case of rational number, also subtraction and division is not associative. If you want, you can try it. So it's a homework for you. You try the associative property in case of subtraction and division, and definitely you will find out that for subtraction and division it is not associative in nature. So let us try the associative property in case of multiplication. Okay, so we will do with the same number which we had taken previously, that is minus 2 by 3, 3 by 5 and minus 5 by 6. So let us multiply. So I have taken square bracket here. So minus 2 by 3 into 3 by 5. Let us close it into minus 5 by 6. So here the answer becomes minus 2 by 5 into minus 5 by 6. So which is equal to, so here it becomes minus 2 into minus 5, that becomes 10 divided by 30. So your answer is 1 divided by 3. The other way round, suppose I will do. So what will be the answer? So I'll write in this way, minus 2 by 3 into, within square bracket, 3 by 5 into minus 5 by 6. So what you will get? Minus 2 by 3 into, so here it becomes minus 15 divided by 30. Minus 15 divided by 30. So now you multiply here, minus 2 into minus 15, that is 30 divided by 90. So the answer becomes 1 by 3. So here, as we have written previously, A into B into C is equal to A into B into C. Correct or not? As this equal to this. So, in case of rational number, multiplication is associative in nature. Multiplication is associative in nature. So please you try at home, whether for, I have just told, you just try and find out for subtraction and division, for all kinds of number, associative property is working or not. Definitely you will find out that it is not associative, but please try and confirm it. Okay, so this is all about the properties of rational number. So I think the concept would have been clear to you. Okay, so in the next class we will solve more number of problems, and also we will start with the exercise problems. Okay, thank you. Take care. Please download the app and follow us in YouTube, Facebook, our website, Twitter and Instagram. Take care.